So now that we have foramen primum developed, foramen secundum developed, now it's okay for foramen primum to close, so it will, and it will close by having septum primum grow down, and the endocardial cushion will actually grow up, and they will grow toward each other, like that, and they will fuse together. Once that has happened, we say foramen primum has closed, but that's okay now because foramen secundum had previously opened, and so we still have a pathway for blood to go from right to left. Next, we're going to develop septum secundum. Septum secundum is going to form on the right side of septum primum. That's an important point, as you'll see in a moment, that septum secundum will be on the right side of septum primum. The other important point about septum secundum is that it's going to be a thicker septum, and it's going to be much more rigid. Septum primum is a thin septum, and as a result of it being so thin, it's flexible. And septum secundum is going to be thicker, and it's going to be rigid. So we'll draw it as a thicker line, and it grows also down from the top of the atrium. It grows down, and it grows down past foramen secundum, goes a little bit beyond where foramen secundum is, and then it finally stops. And that's as far as it goes. So we're finished. We're finished building the septum. And we have septum secundum that overlays part of septum primum, including overlaying foramen secundum, but we still have part of septum primum that doesn't have septum secundum covering it. So that would mean to us, if that's all there is to the septum, that would mean that we'd expect to find part of the atrial septum that's going to be thicker than the other part of the atrial septum that'll be thinner. And if we look into the adult atrium and look at the adult septum, sure enough, we find that there's a thin portion of the septum over here, and we said that that's called fossa ovalis. So the fossa ovalis that's found on the adult atrial septum is the region of the septum formed by only septum primum. So the floor of fossa ovalis is composed of septum primum. The rest of the septum, this thicker part of the septum, is the septum that's composed of both septum primum and septum secundum. Now we see that septum secundum has a free edge right there. And that free edge in the adult will end up being called the limbus of the fossa ovalis. Limbus means lip or edge. The lip or edge of the fossa ovalis. So that free edge of the septum secundum would correspond to that free edge, which is the upper edge of the fossa ovalis. That's the limbus of the fossa ovalis. So we see the reason the adult septum looks the way it does is because it forms from these two septa that partially overlap but not completely. But now let's get back to the functional aspects of the septum. I made a big point over the fact that there has to always be a communication between the right side and the left side. But then you see on this illustration that I took the opening that I had, the foramen secundum, and I covered it over by the septum secundum. And one might initially think that that would mean that I have just killed the embryo. But in fact, I haven't. And in order to understand why not and how this works, we have to take a moment to think about blood flow through the embryonic heart. So let's ask the question, where's the blood coming from that's flowing into the right atrium, to the right side of the atrium? And the answer is that all of the venous return from the embryo, the entire systemic circulation of the embryo, is flowing into the right atrium. But also, in addition to that, all of the venous return from the placenta is flowing into the right atrium because the umbilical vein from the placenta flows into the inferior vena cava. So coming into the right atrium is not only the venous return from the embryo, but also the venous return from the placenta. So a great deal of blood is coming into the right side. In contrast, coming into the left side, the only veins that drain into the left atrium are pulmonary veins. So that means the only blood that can be coming into the left atrium is blood returning from the embryonic lungs. Now, in the embryo, the lungs have a very, very high vascular resistance. The lungs haven't expanded. There's a very high resistance to flow in the lungs. And because of that resistance, very little blood flows out to the lungs through the pulmonary arteries. And since there's very little blood going to the lungs, that means there's very little blood coming back from the lungs, which means there's very little blood coming into the left atrium. So what we're saying is there's a very large flow of blood into the right atrium, a very small flow of blood into the left atrium, which is going to result in the pressure on the right side being higher than the pressure on the left side. As a result of that, there's going to be a pressure gradient, and the pressure gradient will be from right to left. So that pressure gradient, that right to left pressure gradient, is going to be pushing against the septum. Now, as you recall, we said that septum primum is thin and therefore it's flexible. And because it's flexible, that pressure gradient pushing against it bends it. And by bending it, it has pushed septum primum away from septum secundum, creating a passageway through which blood can flow. And that passageway is what's called the foramen ovale. So the foramen ovale, if we had to describe where it is structurally, we would say the foramen ovale starts at the upper border of the fossa ovalis, right where the limbus is. It passes between the two septa, between septum primum and septum secundum, and then it emerges through foramen secundum. So with the pressure gradient going from right to left, that separates the two septa, keeps foramen ovale open, and that pressure gradient will cause blood to flow in the direction of the gradient from right to left. And so therefore we do have that shunting of blood from right to left that we said we needed throughout all of prenatal life. So that's how this embryo and then fetus lives until the time of birth. So what happens at birth? Well, there are two important vascular changes, blood flow changes that occur at birth. One is that the umbilical vein closes down. And with the closure of the umbilical vein, that means all of that placental venous return that was flowing into the right atrium is no longer flowing into the right atrium. So that means that there's a tremendous decrease in the volume of blood coming to the right atrium. The other important change is that the vascular resistance in the lungs dramatically drops when the baby starts to breathe. The lungs expand, the resistance to flow through the vascular circuit drops. With that decrease in vascular resistance, there's a substantial increase in blood flow going to the lungs, which means there's a significant increase in blood flow coming back from the lungs, which means there's a big increase in blood flow into the left atrium. So what we're saying is, at the time of birth, the blood flow to the right side drops, the blood flow to the left side rises, and that results in a reversal of the pressure gradient right after birth, with the pressure on the left side dropping, pressure on the right side rising, and now, immediately after birth, we have a left to right pressure gradient. That left to right pressure gradient again will push against the septum. And again, septum primum is flexible, so it will be able to move. It will get pushed by that pressure gradient, but it gets pushed up against septum secundum. And because septum secundum is rigid and it doesn't bend, septum primum gets pushed against septum secundum, pins it against it, and thereby obstructs the pathway or blocks the flow so that blood cannot get from the left side to the right side. So even though foramen secundum is still there and the fossa ovalis is still there, you can't get from there to there because those two septa are pushed together, and that's called closure of the foramen ovale. So closure of the foramen ovale is a result of a reversal of the pressure gradient that occurs at birth. We haven't added any new structures. We've used what's there, but because septum primum acts basically as a one-way valve, only allowing blood flow from right to left, but not allowing blood flow from left to right because it gets pinned against septum secundum, we've now closed foramen ovale.